Today we're going to be discussing the moment of inertia, which is defined as a quantity expressing a body's tendency to resist angular acceleration. In other words, movement, just like any inertia would be. It results as the sum of the products of the mass of each particle of the body with the square of its distance from its axis of rotation. So it has directly to do with torque. It is directly related to torque, and it's kind of like the sum of the torques that a body would produce. So something with a higher moment of inertia would have a different response to forces than something with a low moment of inertia. In a few moments after our demonstration, you will be asked a question as to why a certain body moves faster down a hill than another body. In this case, we are going to use two bodies of equal mass. One is a solid cylinder made of wood, and the other one is a metal ring. In the case of the solid cylinder made of wood, the moment of inertia would be an average of the different locations of the particles that make up that object. In this case, the total moment of inertia is given by the formula I, moment of inertia, is equal to 1/2 the mass of the object times its radius squared. And that would yield the moment of inertia. Now for the ring, the formula becomes I equals the mass of the ring times its radius squared. As you can see, they are two different formulas. Now we are going to show you the demonstration, and we're going to ask you a question to complete and send in. The question is basically, why does one of those two objects roll down the hill faster than the other two? Now please keep in mind that when I narrated the two bodies going down a ramp, I mentioned that one had a higher rate of speed because it had a different moment of inertia, and I am actually incorrect there. I'm going to ask you to explain, based on these moments of inertia, which one you think would go down the hill first, although you're going to see it happen. But then I would like you to tell me why. In this particular case, the wooden cylinder goes down the hill faster, even though it has the same mass as the metal ring. And the coefficient of friction against the concrete, that has really very little to do with it, if anything. They both have that. So you are to explain why the wooden disc, which you will plainly see goes down faster, why that moves faster because of its moment of inertia being different. And again, you're to explain why that happens.
Hello, my name is Carolina De Leon, and I'm here again for another experimental demo.
Yes, today we're going to show you the moment of inertia. And we have on the ground here, which I will point the camera to, two discs. One is a solid disc, and the other one is a hollow disc. And we're going to see which one has the greater moment of inertia. Both are going to be rolled down the plane at the same time, and the one with the greatest moment of inertia will win. I will explain the moment of inertia to you and why it worked the way it did after we do this little demo. Carolina is going to start the discs rolling down the hill. Carolina, and you can begin whenever you want. There goes the solid wooden disc is ahead of the other one. There it goes, careening off of whatever. We're going to do that one more time. I thought that was really cool. And there they go again. As you can see, the wooden disc hit first and destroyed the railing. No, it did not. Let's see if I can find it. There it is. We found it. And now I'm going to explain why the solid wooden disc went down there ahead of the simple ring type disc.